Find the area of a rectangle with this meters wide and that many meters tall. Now it may help us to draw pictures of these. I mean, maybe, maybe not. So if I had a rectangle here, this can be 10.2 meters, and then we got 8.7 meters here. So if I wanted to find the area of any rectangle, that's length times width, which means I'm going to have 8.7 times 10.2. So multiplying these, I'll ignore those decimal values, just keeping in mind that we'll need them at the end. 2 times 7 is 14, carry the 1, 174. Now I'm in the tens position, but those are all zeros. So I got 1 times 7 is 7, 1 times 8 is 8. And when I add these, I get 87.74. But I still need my 2 decimal place values, so it's actually 87.74 meters squared. There it is. So the circle, to find the circumference, we're going to take, with the radius, we need 2 radiuses and multiply it by the pi. Pi, we're just going to make this equal to 3.14. And apparently, recently, they've been finding new values of pi. Not that you guys care, but I'm only saying that because 3.14 gives us a nice decimal value to go off all the time. Whether you believe it's 3.14 or not, I don't really care either. So, and I'm sure you don't. So that is the circumference there at the beginning. The circumference is 2 times the radius times pi. We'll get to the area, but let's figure out the circumference first. So it would be 2 times 6 times 3.14. 2 times 6 is 12. So 12 times 3.14. Take that back. 3.14. So I can multiply these. 4 times 2 is 8. 4 times 1 is 4. Tens position. I got a 1, 2, hundreds position. And I got 6 and 3. So when I add these together, I get 8. 6, 7, and 3. I kind of ran out of space there. I need 2 decimal places, so this is 37.68. 0.68. That's just the circumference, which is a measure of length, so that's just centimeters straight across. Now, yeah, if we were for some reason looking for thousands and 10,000s positions, then we may use other place values from the pi, but that's not important for us. The area, finding the area of a circle, is pi times the radius times the radius. So this will be 3.14 times 6 times 6. And 6 times 6, we can do that first, would give us 36 times 3.14. 4 times 6 is 24. 12, 14, tens position, hundreds position, that's 18, 9, 10. So I get 4, 0, carry the 1, 8, 10, 13, 9, 11. But I still need these 2 place values, so it'd be 13.04 in square centimeters. There it is. That was for number 4, by the way. So for 5 and 6, diameter is the same as 2 of the radiuses. So if I wanted to find radius from diameter, you just divide it by 2. Half the diameter is your radius. So for 5 and 6, we don't have the space to do it, but the radius is 8 inches. And then we can use those 2 formulas that we had up here. And it would look pretty. But in the meantime, I've got 10 times 15.1 times, we'll just emphasize the multiplication, 12.2. Now, the order of these really doesn't matter. You can say the length and the height or whatever you want and mix up the order because of the commutative property of multiplication as well. But let's do this. 10 times 15.1. So 1 times a 0 is 0. 1 times 1 is 1. Tens position, 5. And then the hundredths position, bam, 1. So 1, 5, 1, 0. But we had one decimal place, so I get 151. And so these two came out to 151. Now I'll multiply this by 12.2. 12.2. I don't really need the 0 there, 0.0. So 2 times 1 is 2. 2 times 5 is 10. Carry the 1, 3. Tens position. 2, 10, 1. Again, that one. Sorry, 2 and 1, that's a 3. Now I'm in the hundredths position. 1 times 1 and 5 and 1. So when I add these, I got 2, 2, 4, 8, 1. And I had one decimal place. So this is 1842.2. And this one is going to be cubic feet, because this is volume, which is three-dimensional. If you had written it as 1842.2 feet cubed, that would be fine as well. This does get a little sloppy after a little bit of work. So, I mean, I'm squaring in the answers there, circling them. Just be careful. I mean, I can usually look at the paper long enough to see the answer and find it and follow your work. But we can kind of clean a lot of that stuff up with the calculator. All right. On this one, we got a swimming pool, which, for our sake, hopefully is in the shape of a prism. Just a box, so that we can draw this very nicely, right? So to do that, we just draw two hopefully similar rectangles, and then we just connect the lines like this. Of course, with modern technology, we can make it look really pretty by doing this to the lines. I don't really care either way. The picture is just to help us to see what the dimensions are. So I can say that my swimming pool is 20.2 meters long. Yes, this is not proportional because I don't care, and I assume you don't either. And it's 5.1 meters wide. And then we'll say it's a 3.5 meter hole. All these are in meters. So if I wanted to figure out the volume of this thing, which is how much water it holds, okay? So that's the nice thing about drawing, and that's one of my problems too, is we fill it with water, which is blue. So to solve for that, we'll just multiply all these numbers together. So I have, it doesn't matter which one we start with. I'm just going to take 3.5 and multiply it by 5.1. So that's going to be 5 and a 3, tens position. Carry the 2. 5 times 3 is 15, is a 17. So I got 17.85 because the 2 decimal places there. And then I'll multiply that by 20.2. Again, the place values, lining them up, doesn't matter. 2 times 5 is 10. Carry the 1. 2 times 8 is 16, plus 1 is 17. 2 times 7 is 14, plus the 1 was 15. Carry the 1. 2 times 2 is 2, plus 1 is 3. You see what I mean by it? It kind of gets a little jumbled up there because I don't know how to make this more exciting. So, where I'm in the tens position now, and that's just a bunch of zeros. So now I'm in the hundreds position. And I've got 2 times 5 is 10, carry the 1. 2 times 8 is, well, we did that one already. 7, 5, and 3. That should save us some time. So, adding all these together, I got 7, 5, that's a 10, carry the 1, 6, and 3. And up there at the top we had 1, 2, 3 decimal places. So I'm going to have 1, 2, 3 decimal places as well, making that 360.57. And again, this is volume, so it's cubic meters of water. I don't care if you put up water, but the volume's good. All right, so let's find the circumference and area of this bike tire. The tire, of course, is usually just a ring, but that makes things far more complicated than we want. So let's look at the diameter, which is 16 inches. The radius is going to be half of that, so I'm going to take 16 divided by 2, which is 8 inches. So to find the circumference, I've got 2 times the radius times pi. which means I'm just going to take 2 times my radius, which is 8 times 3.14. 2 times 8 is 16 times the 3.14. Let's do that over here. 3.14 times 16. There's a 4. Carry the 2. 8 and 18 in the tens position. 413. So I got 4, 2, carry the 1, 0, 5. With 2 decimal places, so that's 550.24. That's the circumference in inches. So there's our circumference. The area on this thing would be pi times the radius, which is 3.14 times 8 times 8. 8 times 8 is 64, so really it's just 3.14 times 64. And again, we can do that. 3.14 times 64. So 16, 5, 4 is 12. Tens position, 24, 8, 8, and a 1. So when I add these, 6, 9, 10, 10, and 2. And with 2 decimal places, that gives me 200.96 cubic feet. Oh, that's square feet. What the heck? Because that's area. All right, but I'm going to use not a calculator. So for these, I like to multiply vertically. So I can change this to 4.6 times 7 like this. Now I'm not lining up the place values like I would with addition or subtraction, and here's why. It's because I really don't care that there's a decimal there. But what I do want to know is how many decimal places we have. Yeah. What this means is that after I finish multiplying, that's how many decimal places I should have in the answer. So by multiplying these, 7 times 6 is 42, carry the 4. 7 times 4 is 28, plus 4 is 32. So we have 322, but we still need this place value from the original decimal, so I just make it that 2, and this ends up being 32.2. Here's the nice thing about multiplying by multiples of 10. Not multiples, but... oh, geez, that's going to bother me. Place values of 10, I should say. If it's 100 like this, really we're just going to move the decimal, but that may be a little bit more confusing. So again, I got 1.023. I'm going to multiply this by 100. And as long as I remember I got 3 decimal values on this thing, I can ignore the decimal. So, well, 0 times anything is 0, so you'd get 4 zeros there. Now we're in the tens position, and you'd get 4 more zeros. Not too bad, but now we're in the hundreds position. So I've got 1 times 3 is 3, 1 times 2 is 2, 1 times 0 is 0, 1 times 1 is 1. And this gives me 0, 0, 3, 2, 0, 1. There we go. But once again, we got these 3 decimal parts right there, decimal values. So the decimal would have to go in front of that 3. Now whether you write in those other zeros there to the right isn't important. There's some science teachers that tell you they are. Right now I'm not concerned about that. I can write it like this. If you do tag those on, well, that's a horrible 0. I'm still going to accept it for credit, okay? It's the same thing. But those zeros are just holding place values. I mean, if you tagged on 3 more zeros, is that a big deal? No. It's the same value. Sorry, so what I was saying at the beginning there is 100 has 2 zeros, so we could just we can just move the decimal 2 times to the right. There it is. All right, so we'll point that out. 1, 2, 3 negatives. So we know our answer is going to be negative, and we can ignore those negatives. So by the order of operations, we'll do 1.3 times 2.5 first. So 1.3 times 2.5. Now this multiplication, again, I'm just going to acknowledge my decimal places and treat this like 13 and 25. So 5 times 3 is 15, carry the 1. 5 times 1 is 5, plus 1 is 6. Now I'm in the tens place. So I got 2 times 3 is 6, 1 times 2 is 2. So when I add these, I get 5. There's a 12, carry the 1. 325, but I need 2 decimal places from the start there. This is 3.25. Now I'll multiply this by 10 times 10. And again, the nice thing about that is I can just move the decimal place as many zeros as I have. So this ends up being 32.5. But once again, that's negative 32.5. There it is. Now, yeah, we could have gone back and we could have done 325 times 10, which would have given us 3250. But where the heck was I looking at? At that point, we had 2 decimal places, so it still would have been right there.